Hi there. Thanks, everybody. It's glad to be here. And it's the first time at HashiConf, but I've been watching HashiCorp for a long time. I'm going to give you a quick run through on what's been going on in the microservices space, and start off with a little bit about myself. I work at a VC firm, and I spend the other half of my time doing consulting for large companies, try and help them move on into the future. There we go. So what I want to talk about is why is this happening now? A little bit about architectures. I'll dig into a little bit of technical detail on a couple of things that sometimes stop working or what's missing, and some challenges I've seen in the monitoring space, and then a little bit about what's next. And I've got more slides than normal for this amount of time, so I'm going to keep going pretty quickly. All right. So what's happening out there in the world? Well, CIOs and executives at large companies are trying to move on from being a cost center to being aligning IT with the business and helping get products developed faster. That's really what's driving everything right now. It's about time to value rather than cost cutting. And that's a big switch that's happened in the last few years. The people that haven't made that switch are finding that they're starting to fall a bit too far behind. But also, they're trying not to get breached, because that's coming up as a bigger and bigger threat. And so they're having to build systems that are more and more secure. So you get this thing, this is my favorite image of this. You said that you wrapped your application in a firewall, you're feeling safe, you could suck your thumb if that makes you feel better, but you're not really safe. You have to build applications that are inherently safe now, while we're trying to go fast. So what's happened is, in the web scale world, we've developed some patterns for doing this, but the enterprises are trying to figure out how do we adopt these patterns, how do we figure out what we do with all of these interesting technologies in order to go fast and be safe at the same time. The web scale companies, like I was at Netflix for a long time, freedom, responsibility, high trust throughout the whole organization. It's sort of natural to be able to go very fast in that environment. So when you apply that to an enterprise, it's a bureaucracy with blame and low trust. And that's actually the way they're built. It's the way they're designed to be built. When organizations get really big, you can't trust every part of the organization. And so you have to build a bureaucracy to manage that. And that's why governments have bureaucracy. That's why big companies have bureaucracy. So it's actually part of the value they have is that they can get large things done. But how do you work in this low trust environment? What we found is that if you break things into smaller chunks, then everything starts working. And what we're finding is if you disaggregate the problems you're trying to solve into small groups that have high trust inside the group and which build microservices and have APIs between them, that this helps. So here's a sort of a monolithic application. Front end and a back end, think of Ruby on Rails or something like that. Because somewhere in this application it handles data that needs to be secure, the whole application has to be secure. You have to go through whatever change process you need for a credit card kind of data for every change you make to this application, because it's one monolithic piece of code. And there's one monolithic database connection which can have anything on it. If you break this into smaller chunks, then you can have the red team here and the green team. The red team goes at whatever rate you need to stay safe, and the green team goes at whatever rate you need to make the customer happy. Right? You start breaking things into chunks. The other thing is the connections into the data. You've got different data sources, and you've got very specific request types into those data sources. You can lock it down. It says this is the only kind of thing that this application is allowed to make to this resource. So there's better inherent security in here. There's better inherent ability to break down what is going on, because you've got single function things that should only be doing that one function. When you have a monolithic back end, it's supposed to do everything. A monolithic front end has to do everything. It's very hard to lock down and put rules around what it should and shouldn't do. So that's a really important thing. Now, if we look at this, I did a whole talk once on segmentation, and the point really is that in the old days, operations people would set up a data center, set up some roles in Active Directory or LDAP, then they'd set out some VLANs, they'd set up some hypervisors, put some IP tables on the operating system, and then they finally give a running VM to some developer to stick something into, or they'd install some code into it that they were given by a developer. That's the old world. And it's very controlled by the operations side, and you've got segmentation of duties, and there's all these things. Unfortunately, the new world looks more like this. And you could sort of use, I guess, Terraform to go from top to bottom on here and say it's all developer-driven. Something that this basically developer-driven infrastructure is the new way. So yeah, you're defining, maybe using Docker Net to, in your Docker Compose files, you say networks and storage. Those things are being set in the application itself. Maybe you're controlling IP tables with something like Calico, using super security groups rather than messing around with your hypervisor. Using VPC instead of VLANs, you're using identity access management systems, and you've got multiple AWS accounts instead of data centers. So this is the new world, and the problem here is operations really has very little control here. There's no segmentation of duties. You've got to set up some compensating controls that basically say we can do this safely. And this is one way you could probably do this. You'd have a bunch of Amazon accounts. You want to have standard practices across accounts. Then you want to have VPCs for fairly large groups within those things, maybe multiple teams, multiple business units have their own VPC. Then you maybe have a security group for each team rather than for each service. And then within each service, you are basically using containers and links to hook them together. So now within a security group, you've got a very high trust group that can go incredibly fast, and you've got a clean interface to the other groups. And you treat other groups as if they were untrusted the same way as you treat an external interface. If you're calling Twilio to do some telecom API, it's the same as calling the person that sits in the cube next to you, right? You have the same level of trust and stability on those interfaces. So it takes a bit more work to set up those interfaces. Now, configuring this top to bottom, I'm not sure if this is exactly what Terraform is designed to do, but it's something like that. You need something that can talk to all different layers in the stack across multiple vendors to coordinate everything together. When we look at how we changed the practices at Netflix, this going back in the early days, we decided that we were going to put our developers on call. And this was the single biggest change we made that changed the way everyone behaved. Right? So all of a sudden, developers learned that they could write really reliable code and that you didn't even have to tell them to stop shipping code on Friday afternoons. It's just put them on call and all these magical things happen. The other thing was that they wanted to come off call occasionally. So then it was really important to train somebody else to be able to look after your code to the level at which they didn't have to call you to fix it. Right. So now you automatically get, peer review, code reviews. You've got some kind of pair programming kind of thing going on, but without actually having to create a process to enforce it or tell people to do it. The only thing you had to do is say, you're on call. The last person that checked code in here is the person we're going to call because we don't know what state it's in because you're changing it 10 times a day. Now, back in the old days when you were changing stuff every 9 months, you could have this handover to operations, and maybe even if you were pushing code every few weeks, you could have a handover, meeting, transfer of information, all these things. But if you're changing something continuously, you have to just own it and deal with it and be cautious about what you're doing. So developers are now responsible for how fast they get things done. Pretty obvious, time to value. They're also responsible because they're responsible for the efficiency of the thing they're running, how much it costs to run something, efficiently auto-scaling things, not turning things off when you stop using them, and being efficient in the way they use resources. And they're also responsible for the safety. This is why Vault's particularly important. It's why you have to, key management and secret management is now a developer concern rather than, oh yeah, they're just going to wrap whatever piece of junk I wrote in a firewall and it'll be safe then, right? So you want to make sure that you're tracking all these things and you're keeping your secrets carefully, and you're doing things in a fine-grained microservice way so you have the appropriate level of security for the thing you're building and lots of isolation. So it's easier to build secure systems when you have them broken into small chunks, because if somebody breaks into one chunk, that chunk can only do one thing. It only has a small number of secrets in it, and it's very locked down for its behavior. So in the old days, we used to have machines. Who here knows the IP address of a machine off by heart, right? You just SSH to the IP address, because it's been there for years, right? That's those machines, right? So those are the data center snowflakes. Going to get rid of those, really. And then we went to virtualization and cloud, and we turned machines over every few weeks, and the machines kept changing their IP addresses, so we started giving them names properly and using DNS and things like that. It's okay because these things live for a little while. Then we found containers where it's really a process with some extra sort of baggage around it to make it more isolated. These deploy in seconds, and it's perfectly reasonable to deploy them. An entire test environment can be stood up in a few seconds and torn down again a few minutes later. That's a very good use case. And some of the early results for Docker found that the most common lifetime for a Docker container was 1 minute, and the second most common lifetime was 0 minutes. And so that also shows a problem with monitoring tools, monitoring things that don't live for long enough to monitor. And now we have Lambda and its sort of in its various clones, which deploy in tens of milliseconds, and running 1/2 a second is just fine, right? So now we've got infrastructure where the cost of a deployment is, well, here's the code. When you want to call it, deploy it for me and run it. That's sort of, if you think about Lambda, it's deploy at runtime. When the request has already arrived, then we're doing the deployment. That's when the code gets taken to a machine, installed, and run. So we've now got this interesting thing that something that used to be really expensive and hard to do, deploying something, is now effectively free. And we're using the fact that this is something you see over and over again in technology. If you see something expensive get cheaper and cheaper and eventually be free, you think, how can I waste this free thing to solve a bigger, harder problem? And the trouble is that a lot of the practice and processes that we developed over the years are built around it being expensive and hard to do deploys. But if they're effectively free, what can you do? So that's the way to think about it. And I think that Lambda is sort of a bleeding edge thing, but it's leading this exploration that's been going on this year as people figure out how to do serverless architectures. I think just after the break, you have Ian from AWS talking about Lambda, if you want to dig in a bit more there. So every time we reduce the cost and the size and the risk of change, we're also increase the rate of change. And these things, it feeds back on itself in a virtuous circle. We've been able to go faster and faster without increasing the risk, because the smaller chunks are easier to debug, they're more secure inherently, and we're able to get them out more quickly. And the cognitive load of figuring out how to modify a microservice is lower. So what is a microservice? Keep talking about this. Here's my definition. Loosely coupled, meaning that you can deploy them all independently. If you have the situation where you've broken everything into small chunks, and then you say, yeah, but to deploy it, we have to alter the tables in the database and deploy all of our microservices to a new version, that's called a distributed monolith. Right? You have all of the pain of microservices and none of the benefits, really. Right? So you have to be able to break these things down into individual chunks that can be deployed independently. That's the real goal. You might have some fairly mature service that you barely touch. It updates whenever there's a new security failure, and you have to do the heartbleed fix to its operating system, and that's really the only change you make to it. And there's another thing that you started building last week that you're changing 10 times a day. Those things should not be in the same code base and in the same release. You separate it all out. The other thing is, how big should these be? And a bounded context is a good idea. There's this domain-driven design, 10-year-old, maybe 11 years old now, book. There's a number of other books on this space. So really, it's not any different to when we have to take a big problem, break it into smaller problems. It's a standard management problem. I have a big problem to solve. I hire some people. I give them different pieces of the work all the way down. Except in this case, when you get to the bottom of that tree of people, each person is deploying their code as a microservice rather than writing a jar file or writing a Go package and blending it in with everyone else's code. There's still some sort of shared packages that go across, but the owner of a piece of business functionality should be deploying an API that does that. That's kind of the new world. So if you're trying to figure out your microservice architecture, you have to fill something into all of these different buckets. And I used to say you could spend 2 weeks sort of trying to fill in a chart like this and arguing about it. And somebody corrected me and said they're still arguing about it after 9 months. So yeah, if you were, the best possible case is you could spend several weeks trying to pick what is the current, counting stars on GitHub and trying to figure out, is this project better than this one, and keep switching it around. And the next slide is I keep changing it every time I give this slide, but there's a whole bunch of things here. These are just names of things that I think are reasonably interesting. Go look them up. There's lots more. This isn't intended to be exclusive, but this is, you have to put something in each of these boxes to go figure out what you're going to do about those different layers in your system. At the bottom, there's a security compliance thing, and what we're seeing here is a bit of bifurcation. If you want to just sort of take scaffolding, if you liked Ruby on Rails because it made you stop thinking about making all these decisions, then you're seeing a lot of people go to Cloud Foundry because it's just scaffolding. It says, we already figured out how to do this stuff, let's just build on top of it and go and do that. And other people are going, no, I have reasons to be different, I'm going to custom build everything. And then those people are using a lot of policy. How do you build your own policy and compliance around that? I think Vault's interesting. I think the Docker Content Trust System's very interesting. There's a lot of policy that you need to build, and you're building your own structures to go faster. So the world is sort of going into people trying to do pioneering work that are on the bleeding edge, and people going, okay, this is now commoditized. There are platforms. I don't need to think about it. I'm building something higher up. So what could go wrong? Let's just look at a bit of systems thinking on the system level here. A bit of technology. So let's say I have all these microservices, and because I wasn't thinking about it too hard, I defaulted everything to 2-second timeout and 2 retries. You probably have something like that in your system. And everything is fine when requests come in and go back. It's all good. But let's say the service on the right fails. What happens? Well, what happens is, this is what happens. Well, the service in the middle keeps trying to talk to it, and the service at the edge keeps trying to talk to the one in the middle, and okay, it's still going. All right, so the service in the middle now makes 9 attempts to call the service on the edge, the right-hand service, and the edge service makes 3 attempts, so the service in the middle is run out of memory, threads, file descriptors, CPU, whatever, but originally there's nothing actually wrong with that service. So if you look at your monitoring system, the service in the middle will be screaming at you, hey, I'm broken. There's a service broken. The actual brokenness is somewhere else in the system, and you can cause cascading failures that ripple all the way back up through your system. All right. So the nice thing about this is it's a trivial fix that doesn't even need you to add any code. You don't even need, some people might go and say, well, quick, implement circuit breakers and pull in all kinds of things, which would help, but the real problem here is that you haven't set it up right. So here's a much better idea. We give this edge service enough time to wait for the things underneath it, but no more. So I need a longer timeout at the edge than the sum of all of the things I'm going to wait for, right? So the downstream services need shorter and shorter and shorter timeouts as you go deeper into them, and fewer retries. I mean, don't keep retrying over and over again. It's like, it's the definition of insanity, doing things over and over again, expecting a different result. Right? If you're calling a service and it fails, don't ask it again, really. Go find somewhere else to solve the problem. But the point here is this service in the middle did the minimum amount of extra work. Now, there's one tweak on this, which is this is the way Netflix and Uber's systems work, which is that they never call the same service. If you have a broken connection, you find some other service, there's a load balancer somewhere in there, you call another one of the same kind and hope that that one's going to succeed. Because that failed service may just be doing a garbage collection for the next 10 seconds and not be listening to you or something like that. So there's reasons to do that. Now, this is fine for small systems that have relatively few tiers in them. As your systems get more and more complicated, it's hard to know where you are in the tree and what your timeout should be. So the actual systems that Netflix and Uber and a few of the more sophisticated systems do is they pass in a timeout as on the request. And every time you pass it down, you reduce it a bit. And when it gets down to 0, you say, I don't have time to respond. So and that timeout is basically telling you how long the edge is going to wait. And if you can't get back to the edge before it stops listening to you, you should just give up and stop worrying about it, right? So that way you can handle a very deep, complex system and not know where you are in it. You just have to have this mechanism. So there's a bit more work here, but it's a powerful way of thinking about it. The nice thing about that, and I really saw one of the companies I was working with had this problem, tweaking the timeouts fixed the problem. You don't have to write code. So think about the systemic behavior of your system. All right, some monitoring stuff. This is the architectures that we're talking about. All right, way too much stuff. It's all too complicated. Everything's talking to everything else. So how do we break that down? Well, I started building a simulator. I was writing some code in Go. You can go play around with it if you want. You visualize it with D3, or you can export it into Neo4j and play with the graphs that it generates. And you can play with it if you like. If you want to track this, SimianViz is the Twitter handle. Every time I do a check-in, it gets an update. So that's interesting. And what I was trying to do was solve one of the problems I saw when I was at Netflix a few years ago, which is how do you visualize and monitor these really large, complex systems? Well, a few weeks ago, Netflix actually released their more recent code, which was built after I'd left, which is called Visceral. This is a global visualization showing 3 regions with all the traffic going in and out, and the thing in the middle is the internet, sending traffic through to all these different places. And in the last week or so, I've written some Go code which interfaces to this, and now I can import and export, and I'm on the process of gluing this onto my simulator as a user interface. And I've written, it's all JavaScript and WebGL and all this stuff. But I know if you want to have a Go library for writing to it, that's what I've been building. So if you look at GitHub, Go Visceral is my toolkit. So this is the top level. If you click on one of the regions, you get this, which is, oh, crap. What's going on here? Lots and lots of things are happening. This is just one region's worth of traffic. If you click on one of those icons, that's an individual service. And now you get down to an individual service context. And this is the real power of microservices. If you just hired somebody into your team, this is the context they have to deal with. You have 3 upstream consumers. You have, whatever, there's 6 downstream dependencies. This code does one thing. Go and modify it, and you're unlikely to break the entire system, right? Whereas if you have a monolith and trying to modify a monolith, it's much more work to understand what might happen and how the whole thing works together. So the idea that you're breaking things down into smaller chunks is actually simpler to deal with if you're developing it and you can bring in people. So it isn't harder to work with this, it's actually easier. All right. So what we've seen here in these architectures is there's a lot of symmetry in there. Every region's the same, every zone's the same, you have the same services everywhere, and this builds out into a very highly available system that is very easy to manage with a small team. Because you've created invariance in the system and you can make stable assertions about what it's going to be doing, and you've tried to get rid of the special cases. So Netflix does, if you watch their little blog post on this, they have demos where they shut down a region, and they do this about once a month. They shut down zones once a month. And what that does is it proves there's nothing special about a zone or a region. So testing the disaster recovery. So how many people have disaster recovery data centers? Yeah, a few. How many have ever failed over to them? A few of it. The best in class, I got somebody said, yeah, every weekend we flip from primary and our secondaries. We flip the 2. We run 1 week on this one, 1 week on this one, and if we ever get a failure midweek, we just push the button and it flips. We know how to do that, right? That is the kind of thing that is easy to do with cloud. It's easy to do with the automation we have today, and that's kind of state of the art, but it's also kind of the best practice now. Having a data center you've never failed over to is just a waste of money. When you actually do fail over to it, you'll find you're not in a happy place. All right, so just a few things about what's next, and I'll wrap up. I brought up serverless recently. You're going to get more about this later anyway. But Lambda is starting to take off. Serverless is an overall name for this. You could argue about whether the name is a good name or not. It doesn't matter that it's the name. It's like microservices. We were arguing about whether that was a good name or not a few years ago. It doesn't matter. So there's the cloud functions and Azure functions are coming. We're starting to see open source builds, so IBM has one, there's Open Lambda, there's Apex.run, and there's a bunch of startups trying to build variants of this. So there's some interesting activity here. It's still, I'd say, pioneer work. If you're one of those organizations that likes to try things out, it's good. It's still not really quite hit the mainstream, although we're starting to see it picking up. And one of the reasons it's picking up, the other problem is monitoring it. This is the monitoring architecture. There's nothing running. There's nowhere to install my agents, right? Okay? Actually, if you use Datadog, you can monitor this for free because there's no cost per node. And Datadog, there's no nodes. But Datadog does actually pull out all the AWS metrics to tell you what's going on with all of your Lambda functions. So I was chatting to Datadog guy yesterday. You've got to figure out a way to monetize this somehow. So this is kind of what goes on. There's these ghosts of instances flickering in and out of existence, and then there's a bunch that weren't called yet, and you don't know why and what's going on. So it's interesting problems. So the programming model is event-driven, it's role-based, it's a very secure model because there's nothing to break into. Where do you attack? There's nothing running to attack. And it's very whitelisted, API-based security. Everything is 100% useful. It's doing useful work. It's 100% utilization. You don't have to have extra capacity, and it's only there when you need to run it. And I have a bunch of anecdotes that the cost of running these environments is sort of 1% or a few percent of the cost of running a normal, having a permanently posted server for things that have reasonably spiky workloads. A lot of internal corporate IT kind of stuff, and low-use websites and things like that. So a lot of work in progress here. You kind of have to, everything becomes APM. You have to wrap things. IOPipe have a thing where they wrap your serverless functions and try to save stuff off. So there's some things emerging here that are looking interesting. But again, monitoring tools, vendor support, this stuff is still a bit emergent. Now, if you try and do it yourself, like say you want to run, I like this serverless thing, but I have my own data center, you need a really low latency way to start a container, really. And so Nomad's actually pretty good at that. And there was some talk at HashiCorp about how they were running lots of sort of event-driven functions in Nomad. So I think you need something that is got the very integrated, very low latency startup. It matters a lot. If you have to do lots of chatter, between lots of different processes to get a container scheduled, then it's too much overhead to get it started. You want something that is very, very rapid and knows what it's going to do very quickly. Then you have to figure out your own charging model and capacity planning. So it's a little bit complicated. Another thing that's going on, another next generation thing, is we're adding machine intelligence to everything. And if you already had machine intelligence, then we'll add some deep learning because that's obviously a lot better. And we'll just keep building these things up. So we're starting to see this in the monitoring space. Instana or somewhere here, StackStorm is a remediation system that lets you code up how to fix things as well as, and it was figuring out how to break, what needs fixing. We're starting to see more role-based personalized user interfaces where there's intelligence built into the systems, the way it interacts with you. And then Netflix has the Spinnaker delivery pipeline, and the bit they didn't open source was the canary testing sort of signature analysis piece, but there's a company called OpsMX who built that and are trying to work on plugging it into Spinnaker. So these things are starting to come back. That's a neural network system which is learning what it looks like to be a good service. And then if it looks different, it'll complain. So that's the sort of, again, this intelligent system we're adding. And then a lot of stuff around event correlation and filtering to try and stop when you're on call, because you're a developer, you're on call, you don't want to get every little alert. You want to start filtering them and combining them into incidents. All right. So challenges in monitoring. There's too much new stuff. It's a bit too ephemeral, and it's still a bit too dumb. We need to add intelligence to make it clever. Okay, I did get a few extra minutes, so I'm going to use up my time here. The other thing that's interesting, this hasn't really happened yet. This is kind of coming, right? Tera services. We'll be able to run machines with terabytes of memory trivially easily soon, really soon. This is starting to happen. And the ability to just grab a machine with a couple of terabytes of RAM to do something is going to drive the open source world particularly, because we'll be able to engulf the data set in memory. We can do huge memcached or Redis or whatever. These are currently very high-end systems. If you want to go and buy something that has a few terabytes of RAM, it's hugely expensive. You go talk to some ops team or whatever people, talk to your executives, hey, I need a 2 terabyte machine, they'll laugh you out. Right? I just need it for a few hours to play with something. That's not going to be a good conversation. Right. And then these things are migrating to be non-volatile. So these terabytes of memory become non-volatile. You no longer really need file systems or databases. They're just going to sit in memory. So enormous graph databases that don't need to persist themselves. There's a few ways to get this right now. That you can do this with flash DIMMs. You can do it with 3D Crosspoint starting to come out from Intel. And AWS announced a 2 terabyte instance for last May for $14 an hour. They're still only just available. You have to sign up and beg them for a while before they'll let you access to one. But SAP HANA was the real driver for this. But I think the ability to get at these systems is going to drive innovation. We're going to see people with open source projects that would not previously be able to say, well, I wonder what happens when you scale this up by another 100x over what I'd normally run on my laptop. Well, it all craps out in all these interesting ways. I can go solve that problem. We'll start to see people take advantage of this and build tooling that goes in there. I'm interested to see where all that goes. All right, so this is my sort of wrap up. we see the world as increasingly more complex and chaotic if we use inadequate concepts to explain it, right? When you understand something, it no longer seems chaotic and complex. So the whole microservices world, some people seems chaotic and complex. And the freedom and responsibility cellular organizations, which are very interacting with each other, again, those seem complex. It's not a centrally planned hierarchical command and control way of doing things or building things. But there are systems that work, like putting developers on call is a systems thinking approach. It provides feedback to put the pain where it can do the most benefit, and the emergent behaviors that come out of that are the things we want. So this is an approach to management and building things where it's systems thinking at the system machine level and at the people level. So it's a great book if you want to read it, and the way to pronounce his surname is Garage Doggy, right? Jamshid Garage Doggy, and that's actually about as close as you can get. So that's it. I'm kind of out of time, I think. So happy to, I'll be around the rest of today, and I'll afraid I won't be here tomorrow, but happy to catch up with anybody, and I'll put these slides up on SlideShare. My SlideShare account has lots and lots of slides on it. So thanks everybody for being here.